Hello everyone. I am Neha Soni, Senior Research Inspire Fellow at University of Delhi. Just because we have talked about a lot of applications, the question comes, is ASR a solved problem? The answer is a big no. The pipeline I discussed how an ASR works in the last video may seem easy to implement, but it is not. Human language is very complex for computers to understand. The computers need to recognize the intentions behind phrases they detect through morphology, syntax, semantic, and pragmatic analysis of the human language. For India specifically, which is an inherently multilingual society with more than 30 languages with at least a million native speakers. Many of these languages overlap in acoustic and lexical content due to geographical proximity of the native speakers and shared cultural history. Additionally, many Indians are bilingual or trilingual, making the use of multiple languages within a conversation. Also, for artificial intelligence problem, more the data, better will be the results, with some terms and conditions. Moreover, using ASR for a new task will require the same level of effort. So, there is a room for development as well as improvement. In this regard, I want to show you all a video. This is a 3-year-old video. I could not find the original creators of the video, but the YouTube link is attached above. So you can analyze after watching the video that what level of understanding is required from the machines to make them a part of our life. In this slide, we look at the current challenges of speech recognition and what development we can expect in the future. First, imprecision and false interpretations. Speech recognition software is not always able to interpret spoken words correctly. This is due to computers not being on par with humans in understanding the contextual contextual relation of words and tenses, causing misinterpretations of word of what the speaker meant to say and achieve. Second, time and lack of efficiency. We would usually assume that computerizing a process would speed it up. Unfortunately, this is not always the case when it comes to voice recognition systems. In many cases, using a voice app takes up more time than going with a traditional text-based version. This is mainly due to the diverse voice patterns of humans, which systems are still learning to adapt to. Hence, users often need to adjust by slowing down or being more precise than normal in their pronunciation. Third, accents and local differences. ASRs are oftentimes challenged when voice inputs divert too much from the average. Especially, accents can pose a big challenge. While systems are getting better, there is still big difference in their ability to understand American and Scottish English, for example. Even a simple cold or dental treatment can be a reason for voice commands not to work as seen in the video. Background noise and loud environments. Whenever there is a too much background noise, speech recognition will be challenged, making it especially hard to use them effectively in the urban outdoors or large public spaces offices. With the use of specific microphones or headsets, the limitations can be decreased, but it requires an additional device which is never desirable. Privacy and data security. For a voice assistant, being able to learn data inputs are needed. These can be generated through paid research or studies, which is very limiting approach, specifically when compared to the sheer endless amount of data that is created through everyday usage of voice systems. Yet, the use of this data must undergo well placed scrutiny as the thought of having all their voice inputs collected doesn't sit well with many people. Most importantly, when these data sets are controlled by large companies that want to make a profit, keeping user data safe can easily become a conflict of interest. Therefore, great challenge of voice recognition lies in making data input available for AI, but still acknowledge the need for data privacy and security. Our aim is to build an automatic speech recognition system ASR based on a mix of acoustic model and language model so that it can determine phonetic units in the language and model the word sequences simultaneously for Indian accent English speakers. The training and testing of the model could be done by making a custom dataset of audio recordings. The final evaluation of the ASR would be done on the basis of word error rate. In the coming videos, we'll discuss in detail the highlighted words that may be new for you. This includes acoustic model, language model, phonetic unit, word sequences, word error rate, etc. Thank you.